factoring experts still miss how to implement those skills in the context of solving an equation, which is really the whole purpose of learning how to factor. It's not just to sort of understand an expression better by breaking it into pieces. It's really about what that strategy can do to help you solve an equation, help you to get x by itself. So now that we've done the factoring step for its own sake, let's look at how that factoring step helps us to solve the problem over here on the right. So we know now, based on the work that we did, that x squared minus 3x minus 18 can be rewritten as x minus 6. Actually, I'm going to follow Nefendi's cue. I'm going to write these in the other order. X plus 3, x minus 6. Again, same difference because multiplication is commutative. So what we've done here in this equation is we've factored. Factor the left-hand side. But then even factoring experts that remember to do this step often are lost as to what to do next. This is a stitch that gets dropped a lot in this class. So I want us not to drop that. I want all of you, when we get to the next exam attempt on the 30th, to know what to do from here. Because it's something very simple, but it's something that people forget because you don't do it with enough frequency in these two modules. So let me go back to Darren. You solved this problem and got the two answers that we got down here at the bottom. But these answers look kind of a little different than our factorization, right? In our factorization, we have x plus 3, but your answer that you got at the end of this equation solving was x equals minus 3. So what's going on in between here, in this gap? What was the next step that you did here? The entire purpose of factoring is that when I have a factored expression on one side of an equation and a 0 on the other side of the equation, it lets me break that equation apart into two simpler equations. And what could be better than replacing a complicated thing with two simpler things? Right? That's the whole purpose of learning how to factor, is to do exactly that with us. So the factor comes first, but the split is the important piece, comes second. And when the split happens, that 0, and we'll talk about the importance of that 0 here in a minute too, but that 0 becomes the right-hand side of two new equations, each of which has one of the original factors in it. X plus 3, x minus 6. And this, again, cannot overstate the importance of remembering this step. Because if you remember this step, now the two equations that we have to solve, they don't need their parentheses anymore, as Darren was saying, so we can just scrub those. And each of these is pretty simple to solve. If x plus 3 is equal to 0, how do I solve it for x? Let's subtract 3 from both sides and get x equals negative 3, which, sure enough, that was one of Darren's original answers. Likewise, x minus 6 equals 0. We solve by adding 6 to both sides and getting x equals positive 6, which was the other of Darren's answers. So the entire purpose of learning how to factor is so that we can do this process. That if I have, and again, the important thing about this equation is that the left-hand side has been factored and the right-hand side is equal to 0. Factored and 0. It allows us to split. And the reason that that works is that in the real number system, it's not possible to multiply two numbers and get a product of 0, right? Blank times blank is equal to 0. The only way to fill in numbers into those blanks is for one of those numbers to be 0 itself, right? There's no way to multiply together two things which are not 0 and get an answer of 0. So if I have a factored expression that's set equal to 0, it means that one of those factors itself had to have been equal to 0 in the first place. That's what allows us to split the one complicated equation into two simpler equations by giving each factor its own equal to 0 and then solving the simpler equation that results. Remember to split. If you have factors on one side and 0 on the other, that should be a Q. Split that equation into simpler pieces and then solve those simpler pieces. People that remember to do the split solve these problems great. people, even the most experts in factoring who don't remember to split, will end up chasing their tail in a problem like this. Sometimes you'll multiply it back out and go back to the original expression and be stuck. Sometimes you try moving some of these terms from the left side of the equation to the right and then turning around in circles and trying to take a square root of things that don't square root, trying to divide by x and ending up in a mess. All kinds of ineffective strategies that don't help us to solve for x. What's missing is that after you factor, if the other side is 0, split it into 2 pieces and then solve each of those 2 simpler equations for x. So here's an equation that I'd like you to solve for x, using everything that we know up to this point in Module 7, which is pretty much everything in Module 7. Take a few minutes, try this problem out, and you can start working with your partner immediately if you want to. See if you can come up with a strategy to solve this using everything that we've learned up until this point. So here are a couple of different approaches that I saw as I was walking around to solving this, and I think that they're representative of some typical approaches that people implement to try and solve these problems. So the first one is the one on the left here. And the approach that was taken here, 2x squared equals 2x plus 40, is to factor the expression on the left-hand side and to factor the expression on the right-hand side. Okay. So on the right-hand side, we factored out a 2 and got x plus 20. On the left-hand side, it looks like we factored out an x and then had a 2x on the inside. Okay. So those factorizations are correct. There's nothing wrong with them. I mean, they both land. X times 2x is equal to 2x squared. 2 times quantity x plus 20 is 2x plus 40. So there's nothing wrong with those. The issue is that it would help us more if we were able to factor out the same thing on both sides of the equation. So on the right-hand side, we factored out a 2. What if we tried to factor out a 2 on the left-hand side instead? Does 2 go into 2x squared? It does. What's the cofactor? 2 times what? Well, 2 times x squared. And that's helpful because why? What can we now do to simplify this equation now that we know that both sides of the equation have a common factor of 2? We can divide by 2 on both sides. And dividing by 2 on both sides will have the effect of undoing the multiplication by 2, and it'll give us a simpler equation that we can solve, namely x squared equals x plus 20. That's good news because that has helped us to reduce this equation into a simpler form before we begin the process of trying to solve it for x. So that's a good instinct to follow. Just when you follow it, try to factor out something which is the same factor on both sides, because then we can get rid of it. So that was this person's first opening step. The work in blue over here on the right used a different first step. What first step was done in this solution process? How did you get from the first line here to the second? In the blue, we're seeing a strategy that instead of privileging factoring first, it privileges, let's get all the terms in this equation onto one side first, which is another good instinct. It's another instinct that we want to follow. And so what was done here is that 2x squared was subtracted from both sides of the equation. And on the right-hand side, that results in the expression which is written down here, negative 2x squared plus 2x plus 40. But something got lost in this process, namely the equal sign. So let's make sure that that gets put in. This is another common thing that happens in solving problems like these, is that the equal sign disappears. What in fact belongs on the other side of the equal sign, since I've done 2x squared minus 2x squared? 0. And that too is really, really good news, because only when we have 0 on one side of the equation can we split apart the factors that we find and give each of those factors its own simpler equation to solve. So getting that 0 in your equation is another top priority. In fact, usually when I solve these problems, I treat that as my top priority. So my step number 1, very often, is subtract all the terms to one side. Because then that's going to make the other side equal to 0. And only if the other side is equal to 0 can we use the factoring and splitting technique that we talked about. So we can now implement the factoring and splitting on this equation. Or, I suppose, we could meet in the middle, and we could do the same subtracting to the equation in orange up here at the top right, and do that same process there. In fact, that's what I think I'm going to do. And I'm actually going to do it by subtracting the two terms on the right, minus x minus 20. And the reason that I subtract those two instead of the other way around is that I like to keep the x squared as having a positive 1 coefficient in front of it, just because, especially at this point in the course, that's a little easier to deal with for us. So I subtract all the terms to one side, and the other side is 0. And then the next step that's written in blue here is the factoring step. Right? And so that's the time to factor and split. I'm going to put then in big capital letters, because we have to do the first step before we do the second step. Then factor and split. And so now we get to do the work of how do we factor, in our example, x squared minus x minus 20. Did anybody get to the point of factoring that? 5 and 4, right. So again, what we did there is we were looking for a pair of numbers which multiply together to give us how much? Right, well, they have to multiply together to give me negative 20, and add together to give me negative 1. And so a 5 and a 4 will at least give us the product of 20. Now we just have to decide which one or ones of them gets a negative sign. So which between the 5 and the 4 do I want to give a negative sign to? The 5, because we need the sum to be negative. The sum needs to equal negative 1. So negative 5 and positive 4 fit the bill, which means that we can factor this expression as x plus 4 times x minus 5. And then the right-hand side is still 0. But because the left-hand side is factored and the right-hand side is 0, that means that we get to do the step that everybody forgets to do, split the equation into two simpler pieces, and solve each one of those pieces equal to 0 separately. But then each one of those pieces is real straightforward. X plus 4 is equal to 0, and x minus 5 is equal to 0. How do I solve the first equation? X plus 4 equals 0? Subtract 4, exactly. So that x equals negative 4. And the second equation, x plus 5 equals 0. Add 5. And our two solutions to this equation are x equals negative 4 and x equals 5. So this used a lot of the tool work that we've built up in this module. Right? We had to, first of all, in this problem, look for some common factors, some greatest common factor across all of our terms. And we found out that all three of the terms in my original equation shared a common factor of 2. That once I factored it out, I could divide it away, and then it was gone. And we had a slightly simpler equation to work with. But then we were still left with the problem that both sides of that equation had terms on it. So we handle that by subtracting all the terms from either the left side to the right or the right side to the left. Make one side of the equation equal to 0. So that's what we did here by subtracting x and subtracting 20 from both sides. Because only when one side of the equation is equal to 0 can we expect to factor and split. Because 0 is the only real number that satisfies this splitting property. Right? That we can split apart each individual factor and set it equal to 0 and be all done.